Welcome to the course MCDM techniques using R. So, in previous lecture we completed our discussion on the introductory part of this course. Now, in this particular lecture we are going to start our discussion on the first technique of this course, first MCDM technique, that is AHP, that is analytic hierarchy process. So, let us start. So, AHP analytic hierarchy process was actually developed by SATI during 1977 and 80. So, as we know that MAUT method, if sometimes it is difficult for decision makers to construct utility function, then AHP could be a suitable MCDM method that can be used to solve decision making problems. So, that is the first point, particularly useful when unable to construct a utility function. Now, if we look at AHP in terms of steps, generic steps to follow to actually follow in an MCDM and MADM method we have covered into the introductory part of the course, introductory lecture of the course. Specifically for AHP we have 4 steps that are required to obtain ranking of alternatives. Typically it is used AHP used to solve ranking decision problems. So, let us talk about these 4 steps. So, first one is problem structuring. So, in this step we structure our problem in the sense the goal, the criteria to be considered and the alternatives to be evaluated and the framing and formulation of the problem and the decision makers who are going to respond. All those things will come under this step that we need to decide. The second step is on priority calculation. So, once we have done our problem structuring, so we know the decision makers, we understand the decision problem, goal, criteria and alternatives. We can take responses from decision makers for with respect to our goal for criteria and with respect to our criteria for alternatives, and these responses are taken in using pairwise comparisons. So, that is what you see here. The priority calculation this step is about is based on pairwise comparisons. And instead of using a numerical scale we typically use a verbal scale. So, a relative verbal appreciation is used instead of a numerical judgment, because as we have talked about in the introductory lecture, it might be difficult for decision makers to use a numeric scale while comparing criteria or alternatives. So, a verbal scale is used and then it is mapped to a numeric scale. Now, problem structuring and priority calculation, these are the 2 main steps of AHP. So, once we structure the problem and we have we do our computation for priority, then AHP will get the ranking. So, the method and implementation would be over. However, 2 recommended steps, 2 additional steps are also there which can also be completed. So, the third step is consistency check. So, this is optional, but recommended. So, what might happen is that because of the number of pairwise comparisons that decision makers have to perform, there might be some contradiction that that could creep into the in the pairwise comparisons that are to be performed, and which might lead to inconsistency in the results, the final ranking that we produce. So, how do we take care of this problem? How do we do a consistency check to find out whether our pairwise comparisons are okay or not? So, that is part of this particular step that is which we refer as consistency check. Then fourth step that is sensitivity analysis. This is optional, but recommended. So, once we have got our results, so how do we confidently say that this ranking is final and is a robust ranking that we have got after applying AHP, and small changes in input values or other variables are not going to change the results. So, robustness of results, how do we find out this aspect. So, that all this comes under sensitivity analysis. So, this is the fourth step, optional but recommended. So, this will give us an idea about how good our results are. Let us move forward. So, now we will start discussing each of these steps one by one. So, let us start with the first one, that is problem structuring. So, the main idea of main idea in this step of problem structuring is that divide and conquer. So, if as you would see in the name of this particular method, AHP, that is analytical hierarchy process, we actually use hierarchical structure there. So, in any typical hierarchical structure you would see one element, and then it is we have two, it is divided into in the next hierarchical level you have two elements, then later on third step you will have many more number of elements. So, it is like a tree like diagram, and it starts from the root node, and we keep on dividing and keep on moving towards more number of elements. So, it is like divide and conquer is the main idea here. So, we are looking to divide we are looking to structure the problem using the hierarchical process. So, how do we typically break down the problem? So, we structure according to a hierarchy, as I talked about. So, there are going to be minimum 3 levels. So, there could be more than 3 levels depending on the decision problem, depending on the criteria that are going to be used. If they are just criteria, sometimes there might be sub criteria. So, within with respect to each criteria there could be number of sub criteria as well. So, that might lead to increase in the number of levels here. However, minimum 3 levels are required. The top level is there is going to be just one element, that is top element, that is goal of the decision problem. So, when you think about a tree and an hierarchical structure, the top element, just one element is going to be there. This element is going to represent the goal of the decision problem, and then we will come down to the second level in the hierarchy, and this second level of the hierarchy represents the criteria. So, the criteria that we might have, criteria 1, criteria 2, criteria 3, criteria 4. So, depending on the number of criteria, we will have those number of branches coming out from the top element of the structure, this hierarchical structure. So, now as I said in the second level which is about displaying structuring criteria, if there are sub criteria within each criteria in the second level, then of course, the number of levels will increase accordingly. Now, the lowest level, which typically is the third level as well in the when there are just minimum 3 levels, then the lowest level represents the alternatives. So, alternatives with respect to, because as I have talked about that there are going to be pairwise comparisons among alternatives with respect to each criterion. So, therefore, the second level branches that we have with respect to each criterion, we are going to have the alternatives which are going to be compared. So, in the third level we will have the alternatives, and the pairwise comparisons would be with respect to the immediate upper level, that is criteria. So, as I said, additional labels representing the sub criteria can also be added. So, this is the main breakdown of the problem. So, we have to figure out the goal, formulate the goal, and then we have to find out the relevant criteria to solve that particular decision problem, and then the alternatives that are to be evaluated based on those criteria and given the goal that we have. So, using these elements, we can structure our decision problem. So, let us discuss further with the help of this example, which is about a shop location problem. So, if we are looking to open a new sports shop, and we are looking to identify locations, so we have a number of locations. So, those are actually the number of alternatives where we can actually open our sports shop. So, these locations are a shopping center, city center, and a new industrial area. So, we have these three location, and we are looking to open a new sports shop. So, how do we arrive at the best location for our new sports shop? So, if we look at the criteria that could be useful for this decision problem, so these criteria could be visibility, competition, frequency and rental cost. So, if we are looking to characterize these alternatives, so what these alternatives are about. So, typically a shopping center is the place where there are more number of people, more number of shops are there, and a generic kind of customers and people would be coming to these shopping center locations. If we talk about the city center, this is more like a happening place where typically youth and other other customers might be arriving, and some events might be organized there. So, if we think about the sports shop, so typically the targeted customer would be youth. So, therefore, city center might be more suitable in that sense. However, shopping center, because it is attracting all customers across the segments. So, therefore, shopping center is also there. New industrial area. So, this industrial area are typically they are outside the city, in the suburban area of the city. It is going to be a new area. So, in terms of customers visiting the area, so that frequency is going to be on the lower side, and mainly people who are working around the area, they would be visiting the place. So, this is the main characterization of these three alternatives, and the characterization itself indicates about what kind of criteria could be useful in solving this decision problem. So, visibility, as we talked about. City center, any shop, any new shop that you open in a city center, it will have a good visibility. Shopping center, higher visibility because of the number of people that will come there for shopping. And then industrial area, probably it will have low visibility because it is outside the city. So, only people in the nearby areas will visit. And then if we talk about the competition, that this could be another criteria that we can consider, because shopping center there would be a number of shops there, same goes for city center. However, in industrial area there might not be enough number of shops or similar shops. So, that is one characterization with respect to competition. If we talk about frequency, as I said, frequency typically would be more on the higher side for city center and shopping center, and on the lower side for industrial area. We talk about the rental cost, then industrial area scores in this aspect, because the rental cost would be on the lower side, because this is outside the city. So, not many people would be looking to rent a shop. So, therefore, the renting cost will come down. Shopping center, there because shops of all kinds would be looking to open, would be looking to rent a place there in the shopping center. So, the renting cost would be on the higher side. Now, city center is going to be the happening area. So, of course, the renting cost is going to be much higher in this. So, given the characterization that I have given and the criteria that I have talked about, and these three alternatives, now we will talk about how we can apply AHP technique to solve this problem. So, problem is structuring step we have talked about, and in that we talked about the three labels: goal, criteria and alternatives. So, here this sports shop, new sports shop, for this a traditional representation of the way the traditional representation of the hierarchy, the way it is done is as you can see in the slide. So, you can see label 1 here, and in the label 1 we have the goal, which is the location of a sports shop. So, this being our goal. So, this is the topmost element. So, as I said, from the top element there are going to be a number of branches. So, you can see label 2. Now, label 2 is for criteria. So, you can see 4 criteria that we talked about: visibility, competition, frequency and rental cost. So, you can see them here in the second label. So, these criteria, when we talked about pairwise comparisons that decision makers have to perform. So, they would be comparing these criteria with respect to the immediate upper level, that is a location of a sports shop, that is the goal of the decision problem. Now, in the Third level we have the alternatives. So, here you would see in the 3 alternatives that we have named here, but if you look at the in terms of number of arrows that are emanating from criteria and 2 alternatives, you can see visibility 4 arrows are 3 arrows are going out, and for these 3 alternatives. So, 1 and then 2 and then 3. Similarly for competition, similarly for frequency and similarly for rental cost. So, these 3 alternatives are going to be compared with respect to each of these criterion. So, this is how we typically structure a decision problem if you are looking to apply AHP. So, top level goal, then we have criteria, and in case we have sub criteria, then there would be another level is going to be added just below level 2, and the last level is typically always going to be the level for alternatives, and then arrows I have already explained. So, let us move forward. So, as I said, each lower level is prioritized according to its immediate level, upper level. So, that is criteria with respect to goal and alternatives with respect to criterion. Appropriate question to ask with regard to prioritization. So, when we are looking to take responses from decision makers while doing these pairwise comparisons among criteria or among alternatives, then how what are going to be the appropriate question that we can ask. So, that depends on the context of the decision problem that we have and also the decision maker. So, based on that we can we can actually frame our questions. So, let us see a few examples. So, SOP location problem that we have discussed. If you are looking to prioritize criteria of level 2, so as I said, there would be this is going to be done with regard to the goal, and an appropriate question would be which criterion is most important for selecting the location of a sports shop and to what extent. So, as you would see that importance of criteria that is being asked through this question, which criterion is most important for selecting the location of the sports shop and to what extent. So, the decision maker would be responding in terms of the verbal scale, and we will talk about what verbal scale is typically used. So, that verbal scale is will be used by the decision maker, and they will express their response using that scale. That would reflect because we are doing pairwise comparison. So, between 2 criteria will get a response, and that would be reflective of importance and the extent of that importance. Similarly, if we talk about prioritizing alternatives in level 3. So, this is going to be with regard to each criterion in level 2, as you can see in the slide, and we have talked about this so many times. Now, an appropriate question for this kind of pairwise comparison could be which alternative is preferable to fulfill the given criterion and to what extent. So, with respect to criterion, which alternative is fulfilling that particular criterion and what extent. So, again the same verbal scale we can use, and the decision makers can give their responses, express their responses using the scale. So, if we talk about this problem, SOP location problem. So, we have just one level for criteria, there is no level for sub criteria. So, one prioritization would be among criteria. So, that is one, and since we have 4 criteria and the comparisons between alternatives have to be performed with respect to each one of them. So, therefore, 4 prioritization would be there for 4 criteria. So, total 5 prioritization would be required. So, 1 for criteria and 4 for alternative. This 4 is coming from because we have 4 criteria there. So, total 5 prioritization. So, this was about the first step that problem structuring, and now let us talk about the second step, priority calculation. So, before we move ahead, let us talk about what is priority. So, by priority what we mean is a score that ranks the importance of the alternative or criterion in the decision problem. So, when we are asking for pairwise comparisons, then it is actually we are looking for that importance to be reflected. So, this score, this is a particular score is going to rank that importance when we are comparing criterion to criterion or we are comparing alternative to another alternative. So, this is a priority. So, in this step we will talk about the steps that are required to compute this. So, typically there are three types of priorities that we have to calculate. The first one is criteria priorities. So, first among the criteria we have to do comparisons, pairwise comparisons. So, based on that we will be computing criteria priorities. Then alternative priorities is there. So, with respect to each criterion we are going to we are going to we are going to have pairwise comparisons. So, that information is to be used while we are computing alternative priorities. And then global priorities, where we typically combine the criteria priorities and the alternative priorities that we have got in the previous steps, and then we compute the global priorities. So, these three types of priorities are there. So, let us talk about each one of them. So, criteria priorities, as I said, importance of each criterion with respect to the top goal, that is reflected. In the alternative priorities, importance of an alternative with respect to one specific criterion. So, that is reflected. In the global priorities calculated using the criteria and alternative priorities, as I have said. So, this global priority is actually going to reflect, actually going to indicate the rank. It is going to rank alternatives with respect to criteria and consequently the overall goal. So, this is about the different types of priorities that we need to calculate. Now, how this calculation, how this computation is actually performed. So, the same technique is used whether for criteria prioritization or for the alternative prioritization. So, this is pairwise comparisons that we use. So, why pairwise comparisons are used? It is understood that typically if we are looking to express a preference. So, we are asked to give preference among a number of elements, number of items, then it might be difficult for us to give a certain importance, indicate a certain importance if there are more number of items. However, if we are just comparing just two elements, then it might be easier for us to compare these two and indicate the importance. So, that is why the pairwise comparisons they are considered to be easier and more accurate to express a preference. That is why it is preferred. And in terms of scale, so typically we use a fundamental 1 to 9 scale. So, there are other scales also which are available, which have been used also. So, for example, 1 to 5 scale can also be used, but sometimes analysts and researchers might feel that the level of detail that is to be captured might not be adequately might not be adequately captured by this 1 to 5 smaller scale. So, probably they will need a higher scale 1 to 9 scale. So, that is why 1 to 9 scale is the most popular scale, most used scale. Some people have also suggested 1 to 100 kind of a scale, a much larger scale that can also be used, but of course, it is going to be very difficult for decision maker. The decision maker might get lost while expressing their preferences when using such a large scale, 1 to 100 scale or other scales. So, other scales are there, they are in use as well, but typically most popular being the fundamental 1 to 9 scale. So, let us now see the conversion from verbal to numerical scale. So, as we talked about that we take responses from decision makers using this verbal scale, you can see in the slide. So, first column is reflecting the degree of importance. Here you can see 1, 2, 3 up to 9, and what we mean by 1 so it is indicating equal importance. 2 is indicating weak importance, then 3 moderate importance, then 4 moderate plus, 5 is strong importance, 6 strong plus, 7 very strong or demonstrated importance, then we have 8 which is very strong, and then 9 extreme importance. So, we would see it's like a increasing scale 1 to 9 scale, and given 2 criteria or 2 alternatives, the decision maker are supposed to express their preference using the verbal scale, and then it is can easily be converted into a numeric scale, as you can see in this table. Now, let us talk about comparisons. So, comparisons are typically collected in a matrix. So, as we talked about in the hierarchical structure that we talked about, because first the comparisons would be among criteria. So, 4 criteria that we have for soft location problems, it is going to be 4 versus 4. Each criterion is going to be compared with some other criterion in the set. Similarly, for alternatives, we are going to collect the data again in a matrix format. So, each alternative, so we have 3 alternatives. So, we are going to have 3 by 3 matrix. So, each alternative is going to be compared with the another alternative with respect, of course, with respect to a specific criterion. So, one example you can see here in the slide. So, this is a comparison matrix for the soft location problem that we are discussing. So, we have 4 criteria here, as you can see. So, we have 4 rows and corresponding to each criterion, and 4 columns corresponding to again each criterion. Now, visibility compared to visibility is going to be 1. So, the diagonal elements, as you can see, they are all 1. So, the main comparison are actually either in the upper triangular part of it or the lower triangular part of this matrix. You would also see that if you are comparing visibility with competition, so this value, and when we are when we are comparing competition with visibility, so this value. So, you would see that this is kind of repetition here. So, actually the number of comparisons, the number of actual comparisons can be reflected either by the upper rectangular matrix or the lower one. So, this is in a sense reciprocal matrix. So, let us talk about the comparison matrix in a more detail. But before we go there, one important aspect here is in terms of numbers, as you can see the scale we saw 1 to 9. So, if we are comparing visibility with a competition. So, here you would see a value of 1 by 4. So, this is actually indicating that competition is being given more preference in terms of visibility, right. So, similarly, if we look at frequency and visibility, so this value is 5. So, you can see frequency is being given more importance in comparison with visibility. So, what we mean by these numbers actually 5, 4 and all those numbers that we have seen in the scale itself. However, when we say 1 by 4, so it is the you can take it though this is for visibility with competition, but value of it being 1 by 4, it actually means that competition is being given more importance with respect to visibility. Now, let us talk a bit more about comparison matrix. So, all comparisons are positive, as you can see we also saw the scale. So, all comparisons, all values are going to be positive. Comparisons on the main diagonal are 1, as I said, a criterion if it is compared with itself, that the value is going to be 1. The matrix is reciprocal, as I discussed. The upper triangle is the reverse of the lower triangle, because it is the same comparison, that's just the different way of representing the same information. So, that is there. Then if we want to find out how many necessary comparisons one has to perform, so that we can derive using this formula n square minus n divided by 2, where n is the number of elements. So, if we look at the previous matrix, this was for criteria, this is 4 by 4 matrix. So, if we look at this, then we have then we had 16 values in this matrix. So, which is reflected by n square. So, we had 16 here, and then there are diagonal elements. So, which are comparison with itself, comparison of element with itself. So, if we subtract this, right, and then since the upper triangle is the and the lower triangle, those values it is just the reverse. So, we are just dividing this number by 2. So, this will give us this formula in this sense will give us the necessary comparisons that are required in each comparison matrix. So, required number of comparisons can be very high. So, if you increase the value of n, then of course if there are more criteria to be considered, then of course the required number of comparisons will go up. Similarly, if there are more alternatives to be evaluated, then of course the required number of comparisons will go up. So, these comparison matrices that we talked about, whether for criteria or for alternatives. So, these are actually used in the software to compute the to calculate the priorities for criteria and alternative. So, in that sense, comparison matrices become input for different functions that we use in software for MCDM, and then output is produced in terms of priority in terms of priorities and weights. So, in this course, as I have talked about, we are going to use R platform. So, we will see in coming lectures what functions and how the input is used to compute priorities and the ranking. So, at this step we would like to stop here, and in the next lecture we will start our discussion on the third step of analytical hierarchy process, which is on consistency check. So, as I have talked about why we need to perform consistency check, and what are the different reasons because of which these contradictions might appear there in the comparison matrices, and how do we ensure, how do we find out how much consistency, how much minimum consistency is required. So, all this we will discuss in the next lecture. Thank you.